For our final exam objective, let's take a look at secure data and applications. In this section, we have three primary areas to break down. The first being configure security for storage. Lots of topics in here. Configuring access control for storage accounts, key management for storage accounts, Azure AD authentication for storage. One of the newer topics, configure Azure AD domain services authentication for Azure Files. Shared access signature has been around for a long time in the exam, still popular. Shared access policy for blob or blob container. Configure storage service encryption. New topic, configure Azure Defender for storage. The second category is configure security for databases, where we can enable database authentication, enable database auditing. New topic that I observed, configure Azure Defender for SQL. SQL database advanced threat protection, database encryption, and database always encrypted. And finally, the third part of this is configure and manage Key Vault, where we talk about manage access to Key Vault, manage permissions to secret certificates and keys, configure role-based access control usage in Azure Key Vault, manage certificates, manage secrets, configure key rotation, backup and restore of Key Vault items, and another new topic it looks like is configure Azure Defender for Key Vault. Azure Defender for Storage provides an additional layer of security intelligence that detects unusual and potentially harmful attempts to access or exploit storage accounts. This layer of protection allows you to address threats without being a security expert or managing security monitoring systems. Security alerts are triggered when anomalies in activity occur. These security alerts are integrated with Azure Security Center and are also sent via email to subscription administrators with details of suspicious activity and recommendations on how to investigate and remediate threats. The service ingests resource logs of read, write, and delete requests to the blob storage and to Azure Files for threat detection. To investigate alerts from Azure Defender, you can view related storage activities using Storage Analytics logging. To investigate alerts from Azure Defender, you can view related storage activities using Storage Analytics logging. Azure Defender for Storage is currently available for Blob Storage, Azure Files, and Azure Data Lake Storage Gen 2. Account types that support Azure Defender include General Purpose V2, Black Blob, and Blob Storage accounts. Azure Defender for Storage is available in all public clouds and U.S. government clouds, but not in other sovereign or Azure Government Cloud regions. Accounts with hierarchical namespaces enabled for data lake storage support transactions using both the Azure Blob Storage APIs and the Data Lake Storage APIs. Azure File Shares support transactions over SMB. Take a look at this link on how to set up Azure Defender, and better yet, try it yourself and poke around the configuration options. When storage activity anomalies occur, you receive an email notification with information about the suspicious security event. Details of the event include things like the nature of the anomaly, the storage count name, time, storage type, potential causes, the investigation steps, and remediation steps. The email also includes details on possible causes and recommended actions to investigate and mitigate the potential threat. Alerts will be generated by unusual and potentially harmful attempts to access or exploit storage accounts. Azure Key Vault is a cloud service that safeguards encryption keys and secrets like certificates, connection strings, and passwords. Azure Defender for Key Vault is an Azure native threat protection service which detects unusual and potentially harmful access to Key Vault accounts. It provides an additional layer of security intelligence for the keys, secrets, and certificates stored in the Azure Key Vault by alerting you to suspicious or malicious access. This layer of security allows you to address threats without being a security expert and without the need to manage third-party security monitoring systems. When anomalous activities occur, Azure Defender shows alerts and optionally sends them via email to relevant members of your organization. These alerts include the details of suspicious activity and recommendations on how to investigate and remediate the threats. There are two ways to enable Azure Defender for Key Vault. You can do this from within Azure Security Center, or you can enable it directly inside of Key Vault. Make sure you review the link at the bottom of the slide to walk through the process to better understand the configuration possibilities. Azure Defender for Key Vault alerts show up on Key Vault and Azure Security Center. You can view alerts on the Key Vault's security page, then go to the Target Key Vault from Azure Portal, and from the Key Vault's main menu, select Security under Settings. To view alerts in the Security Center Security Alerts page, go to the Security Center from Azure Portal. Then from Security Center's main menu, select Security Alerts under General. Azure Files supports identity-based authentication over Server Message Block, or SMB, through two types of domain services: on-premises Active Directory Domain Services, or ADDS, and Azure Active Directory Domain Services, Azure ADDS. Before you enable Azure AD over SMB for Azure File Shares, make sure you have completed the following prerequisites. First, select or create an Azure AD tenant. Should have that already, hopefully. Number 2, enable Azure AD Domain Service on the Azure AD tenant. 3, domain join in Azure VM with Azure ADDS. Make sure that you note Azure Active Directory Domain Services authentication over SMB with Azure File Shares is supported only on Azure VMs running on OS versions above Windows 7 or Windows Server 2008 R2. 4, select or create an Azure File Share. And 5, verify Azure Files connectivity by mounting Azure File Shares using your storage account key. You want to verify that your VM and file shares are properly configured by trying to mount that and using that account key. To enable Azure ADDS authentication over SMB for Azure Files, you can set a property on storage accounts by using the Azure Portal, Azure PowerShell, or Azure CLI. Setting this property implicitly domain joins the storage account with the associated Azure ADDS deployment. Azure ADDS authentication, or SMB, is then enabled for all new and existing file shares in the storage account. Keep in mind that you can enable Azure ADDS authentication over SMB only after you have successfully deployed Azure ADDS to your Azure Active Directory tenant. To access Azure Files resources with identity-based authentication, an identity, a user, group, or service principal, must have the necessary permissions at the share level. This process is similar to specifying Windows share permissions, where you specify the type of access that a particular user has to a file share. We've introduced 3 Azure built-in roles for granting share level permissions to users. Essentially, it's reader, contributor, and shared elevated contributor, all for storage file data SMB share. One important note is that full administrative control of a file share, including the ability to take ownership of a file, requires using the storage account key. Administrative control is not supported with Azure Active Directory credentials. After you assign share level permissions with Role-Based Access Control, or RBAC, you must assign proper NTFS permissions at the root, directory, or file level. Think of share level permissions as the high-level gatekeeper that determines whether a user can access a share, whereas NTFS permissions act at a more granular level to determine what operations the user can do at the directory or file level. Azure Files support the full set of NTFS basic and advanced permissions. You can view and then use Windows File Explorer or running the Windows iCackles or set-acl command. To configure NTFS with super user permissions, you must mount the share by using your storage account key from your domain joined virtual machine. Follow the instructions in the next section to mount an Azure file share from the command prompt and to configure NTFS permissions accordingly. Again, make sure you review the link at the bottom of this slide to learn how to mount that share from command prompt, configure NTFS permissions with Windows File Explorer, and also mount a file share from a domain joined VM. This article, along with the flowchart you're looking at, will serve you well on questions on this topic. An Azure Storage account uses credentials comprising an account name and a key. The key is auto-generated and serves as a password rather than as a cryptographic key. Key Vault manages storage account keys by periodically regenerating them in storage account and provides shared access signature tokens for delegating access to resources in your storage account. You can use the Key Vault Manage Storage Account key feature to list or sync keys with an Azure Storage account and regenerate or rotate the keys periodically. You can manage keys for both storage accounts and classic storage accounts. An Azure Active Directory tenant provides each registered application with a service principal. The service principal serves as the application ID, which is used during authorization setup for access to other resources via Azure Role-Based Access Control, or RBAC. Key Vault is a Microsoft application that's pre-registered in all Azure AD tenants. Key Vault is registered under the same application ID in each Azure cloud. Use the Azure CLI AZ role assignment create command to give Key Vault access to your storage account. Then use the Azure CLI AZ Key Vault-set-policy commandlet to update the Key Vault access policy and grant storage account permissions to your user account. You can also ask Key Vault to generate shared access signature tokens. A shared access signature provides delegated access to resources in your storage account. You can grant clients access to resources in your storage account without sharing your account keys. A shared access signature provides you with a secure way to share your storage resources without compromising your account keys. Make sure that you understand how to create SAS tokens and what the configurations are for this exam. Always Encrypted is a feature designed to protect sensitive data such as credit card numbers or national identification numbers, for example, U.S. Social Security numbers, stored in Azure SQL database or SQL Server databases. Always Encrypted allows clients to encrypt sensitive data inside client applications and never reveals the encryption keys to the database engine. Always Encrypted provides a separation between those who own the data and can view it and those who will manage the data but should not have access. By ensuring on-premises database administrators, cloud database administrators, or other high-privileged but unauthorized users cannot access the data, Always Encrypted enables customers to confidently store sensitive data outside of their direct control. This allows organizations to encrypt data at rest and in use for storage in Azure to enable delegation of on-premises database administration to third parties. Randomized encryption uses a method that encrypts data in a less predictable manner. Randomized encryption is more secure but prevents searching, grouping, indexing, and joining on encrypted columns. Always Encrypted uses two types of keys, column encryption keys and column master keys. A column encryption key is used to encrypt data in an encrypted column. A column master key is a key protecting key that encrypts one or more column encryption keys. The initial setup of Always Encrypted in a database involves generating Always Encrypted keys, creating the key metadata, configuring encryption properties of a selected database columns, and/or encrypting data that may already exist in columns that need to be encrypted. Please note that some of these tasks are not supported in Transact SQL and require the use of client-side tools. As Always Encrypted keys and protected sensitive data are never revealed in plain text to the server, the database engine cannot be involved in key provisioning and perform data encryption or decryption operations. You can use SQL Server Management Studio or PowerShell to accomplish such tasks. Transport Data Encryption, or TDE, helps protect Azure SQL Database, Azure SQL Managed Instance, and Azure Data Warehouse against the threat of malicious offline activity by encrypting data at rest. It performs real-time encryption and decryption of the database, associated backups, and transaction log files at rest without requiring changes to the application. By default, TDE is enabled for all newly deployed Azure SQL databases. TDE cannot be used to encrypt the logical master database in SQL database. The master database contains objects that are needed to perform the TDE operations on their user databases.